Okay, question 12. Looks like we've got three more questions to go, so we're getting there. We're getting there. The diagram below shows a circular cross section of a milk tank. Okay, I think we can agree there's no more useful information there. Let's score that out. The radius of the circle, center O, is 1.2 meters. Okay, so radius is equal to 1.2. The width of the surface of the milk in the tank, represented by ml in the diagram, is 1.8. That's 1.8. Okay. Calculate the depth of the milk in the tank. Okay, so I want to work out depth of milk. No problem. So again, you should be looking at this question and noticing the pattern in a lot of these exams is at some point there's usually a circle with a chord drawn in, and we have to work out something like the depth or this height in here. But yeah, usually a circle with a bit missing. It's pretty common. There was a snowman question. I actually can't think of another one, but they are quite. In fact, I'll do 2016 paper. Let's have a look. I'll bet you there's one in here. Let's see. Yeah, there you go. 2016. We've got this kind of question with the label and the circle. So you maybe see some of the work in there. 2017. I'll bet you there's something in here with a circle. There we go. No, that's the volume. Yeah, there we go. So it was like a logo with circle. So it is a very popular question, and they love it. But it's actually very, very straightforward. Okay, so the only bits of information we've got is the radius and this length, and we're trying to work out depth. Okay, so first of all, I would say, well, what is the depth? Well, if I zoom in, we could break it into two parts. Okay, we could say that we'll use a smaller pen size, I think. So the depth is going to be this bit in here, okay, which we don't know, plus this bit in here, which we do know, because this is the radius, isn't it? Okay, so the depth of milk is r plus x. Okay, so that's what we should be thinking when we see these questions. And how do we work out what x is? Well, we're going to have to make a right angle triangle. Okay, because we know that this and we know that this are going to give us a right angle triangle here and here. We just need one of them, but the point is a radius goes from the center to the circumference. So if we kind of sweep round, eventually we find this bit here, and this gives a nice little right angle triangle. So from this, we can work out x. If we add on r, we get the full depth. Okay, so very common questions, but really it just breaks down to a Pythagoras question. Okay, so let's start off with a diagram. Okay, so we'll just say we've got a right angle triangle that's like this, and 1.8 is the full width, so we're going to have half of that, aren't we? Because we're just looking at one of these right angle triangles. We're just going to look at, right now I'm looking at this side, you could have looked at that side, okay? So just this length here, that is 0.9, okay? I know that I'm trying to find x, and I know that this is the radius, which is 1.2, okay? So how do we work out what x is? Well, it's going to be a Pythagoras takeaway. So I'm going to do 1.2 squared minus 0.9 squared square root. That's going to give me x. Okay. So if we do that on our calculators, we should find that x comes out as 0.79, and that is in meters. Okay. And the final part of the question is saying, well, what's the depth of milk? So the depth is going to be 1.2 plus the 0.79. Okay, so that's going to be 1.99 meters. So it looks like they've thrown a wee stinker at the end of the exam, but really they haven't. It's pretty straightforward question actually. You see a circle, you see a chord. The only hard part is finding the right angle, but basically it's a Pythagoras question. If someone gave you this, you could solve it. Okay, so please don't be stressed out when you see this. So the first mark you get is for actually just identifying the right angle triangle. The second mark is for this. Third mark is actually for your 0.79, so that's fantastic. 3 marks already. And then the fourth mark is just for adding on the radius as well. Okay, so if you know nothing else, if you're not even sure about how to work it out, just remember This will involve Pythagoras, do some form Pythagoras. Okay, so you just lost 1 mark if you didn't realise about the radius at the end there. So not the end of the world. Okay, but yeah, please, Pythagoras. When you see a circle with a bit missing, think Pythagoras. Okay, you're just trying to find this triangle. That's the hard bit. Okay, good stuff. Right, time. Where are we at? Loads of time. Loads of time. Okay, question 13. In the diagram below, P, Q, and R represent positions of Portlaoise, Queenstown, and Rushden. Okay, so I can see that. Portlaoise is 25 due south. That's shown. Bearing 72, that's shown. Now this doesn't seem to be shown. From Queenstown, the bearing of Rushden is 128. So from Queenstown, the bearing of Rushden is 128. So that's not shown. So this bit in here is 128, not shown. That's interesting, they never showed that. Calculate the distance between P and R. So P, so X. Okay. So 4 marks. Interesting. Do not scale, that's fine. So we're just going to be using an equation. So we're trying to find X. We know one length and we know one angle. Now, if we knew another length, we could be using the cosine rule, but I don't think we can work out another length. However, we've been given an angle. They've tried to kind of hide it almost, haven't they? They gave it in the question, but then not shown it. So that's almost like they're trying to test our knowledge. Do we know what a bearing is? Which is that it's from north to the line we're looking at. Okay, so from bearing of 200 degrees, we'd be going round like this. Okay, that'd be 200 degrees. We're going from the north all the way around. Okay, 180 is due south, 270 would be due west. Okay, okay. So first of all, I think that was probably what they wanted us to do, is identify bearings. That's probably worth a mark, right? But yeah, we know 2 lengths and we know 1 angle. If we knew another angle, we could use the sine rule, couldn't we? Now, could we work out what this angle is in here? Absolutely we can, because we know that on a straight line, angles add up to 180. So this is going to give us 52, isn't it? So now we're in a position to use A over sine A is equal to B over sine B. Not difficult at all. Again, big diagram, lots of words, but really it boils down to this equation, which has got 4 variables. 2 have been given to us, obviously. 1, it's been don't find it, and then we just need to work out this other value. Okay, so forgetting the 52 degrees just now, let me just put in, I'll say x over, I'll just leave out that sine A is equal to, oh, in fact, there's another little bit of though, that's interesting. Yeah, you know what, before I go into that, that's interesting. So this was all given to us, okay? We've worked this out. Now, for this equation to work, I need angles opposite lengths. So when I was trying to work out this length, I was thinking, okay, well, I definitely need this angle over here, don't I? Because I need the angle opposite the length. So that got me thinking, well, I'll have to do something with 128, so that's fine. But now, I also actually need this angle, don't I? There's a little sneaky bit. Okay, so I think I maybe said in videos before, what if they gave you this angle or that angle? This is probably a classic mistake where people use this angle, okay? But no, if they've given us this length, we need to use that corresponding length. And that goes back to the triangle diagram that like I said, I've drawn a few times. So we've got A, B, and C, and the corresponding angles for that. A is opposite it, isn't it? Opposite B, yeah, opposite C, okay? So that's interesting. What they've made you then do is say, well, what's 52 plus 72? 124. Oops. 124. And 180 in a triangle. So then 180 minus 124. So that's going to give us 56 degrees. Okay, so this angle in here is 56, and that's the angle we need to use. Okay, so I'm just going to rub out this. If we substitute into our equation now, we're going to have x over sine of 52 is equal to 25 over sine of 56. Okay, so that's quite interesting. They've tried to to dress it up into a trickier way than other questions by giving you this false angle. Actually, that's very interesting. And then they made you think about what a bearing was by putting it in the question, but not having it up here. So again, always worth reading the question. So yeah, that's quite good. There's a wee bit in that to set your question up more so than other questions. Okay. Now we want to get x on its own, so we need to move sine of 52 over. So on the left, I'm dividing by sine of 52. So to move over, I'm going to times by sine of 52. Okay, so times by sine 52 divided by sine of 56. Okay, and that's it. So yeah, let's do that on the calculator. X is going to be equal to 23.8, and our units are kilometers. Nice one. Okay, so marks. You're getting a mark for knowing 52 degrees. You're getting a mark for doing this setup. You're getting a mark for rearranging, and your final answer. Okay, so I think that was actually a wee bit tricky. I could see pressure and time kind of stressing people out and rushing. But the point is, when you see two lengths, so an unknown and a known, two lengths, you're thinking sine rule. And then you're thinking, well, what do I need? If I know these two lengths, I need the opposite angle. Do I know this one? No, but I know this one, so that's easy. And then, do I know this one? I know the other two in the triangle. Okay, so take your time, have a wee think. But yeah, sine rule when you've got two lengths. And your bearings are all from north all the way around. Okay, so for example then, what's the bearing from Rushden to, was it Port something or other? Okay, well that would be all the way around like this. Okay, now how do you actually work that out? Someone asked you. Well, here's just a wee aside. If you know that's 72, okay, the norths you can consider to be parallel, can't you? So we know that's 180 north to south. That angle in there is going to be 72. So the bearing from R to P is going to be 180 plus 72. So that's going to be 252. Okay, so there's another little thing that I think that's come in once actually before, was working out the bearing. So remember your north to south is 180, and these norths are parallel. Okay, so that angle in there. Okay, so R is at a bearing of 72 from P, but then R to P, the bearing is 180 plus the 72, which is 252. Okay, might come in handy. All right, so yeah, you might see the answers in these videos and be like, oh, that's fine, cool, I'm gonna move on. But I'll try and throw in a few extra bits just to think around things that you could get asked. Okay, so yeah, the north, east, south, west, they'd all be parallel lines. Okay, so don't forget your that's a Z angle or an alternate angle, which is probably called. Okay. Question 14. This is the last question now. I think I'm just going to take a separate video for this because I've got about a minute left. All right. So yeah, bearings on that one and Pythagoras on here. I think we can all agree this comes up an awful lot. So please, please, please just know to identify the question because the working is so easy. Okay, Pythagoras add, Pythagoras take away. I didn't really go into detail about why that is actually, to be fair. But yeah, Pythagoras is for right angles only. The actual equation is a squared plus b squared is equal to c squared. Okay, so if you know the two short lengths, you just square them and add them together. That'll give you the square of the long length. So if you want to then work out c, you just say, well, the square root is equal to c. Okay, but if you're doing the takeaway, okay, so say you're told, you know, this and this, you want to find b, well, you're solving for b. So how do you rearrange for b? C squared minus a squared is b squared. Yeah, so to get b on its own, you would just do the square root again. Okay, so we just call it Pythagoras add, Pythagoras take away, but that's all it is. Yeah, the square of the two shorter lengths doesn't look like a square, so it has the worst square ever. The square of the two shorter lengths is equal to the square of the longer length. Okay, and actually that's what, when you think about what a square is, you know, it's this length times this length, you actually would form a square. Okay, you've maybe seen it with the with actual squares that works out. Maybe get something like this, and then those squares add up to the number of squares in this one. I've just drawn a little 3, 4, 5 triangle here. If you do it on square paper, that would actually work out. Okay, as a little proof. Okay, so 3 squared is 9, 4 squared is 16, 5 squared is 25. So if you were to do that on square paper, you would see that works out. Okay, so but yeah, next video, question 14.